So the topic today I'll talk about like very simple, like what is this distributed system? And who already here like working with distributed system already? Probably like all of us, right? We all knew distributed system, but what is it? So I thought it would be good to like just go through the process of like what is distributed system, and then I will introduce about like I will review about like CAP theorem. Basically, this is like CAP. This is consistency, availability, and partition tolerance. Those three promises in this distributed system, and then I'll move on to some policies of distributed system. So in this section, I'll talk about some failing assumptions. Assumption when a developer working in the distributed system and he or she may assume something that's not really correct. And then moving forward, I'll review some problem and the design pattern that fix that problem. Going one by one, starting from CQRS, event sourcing, and then enterprise service bus, and then publisher subscriber pattern, and then finally I will have some demo on PubSub pattern using AngularJS. So, I mean, every topic here is fairly a big topic. So my goal is just like going like 1,000 footprint to go through like quickly, like what is it, what problem that pattern solve, and then it kind of a review. So I didn't mean to like go into detail, like what is it, how to implement that thing in details. So that's my goal. So at the end of the presentation, I hope all of us will have some sort of like review about, okay, when we work in distributed system, what we need to be like care about, and what is the watch out, and what are some good patterns that we can take a reference to have a good design at the beginning of the system. So, what is distributed system? We all know, we all work with distributed system, but what is the definition of it? Can somebody share with me what do you think about distributed system? Matt, what is distributed system?
I would say a system that has the same kind of things running on different platforms that are meant to scale software, right, or provide reliability.
Yep. So, yes, correct. So in distributed system, we have the components. We have not 1, not 2, not 3, not 4, and those components are talking to each other. And the way that they talk to each other is by sending the message. So they're not talking directly, hey, shake hand or something like that. So this is separate note. And then, so what I learned from the definition is distributed system is a system where we have multiple components talking to each other over the communication channel by sending the message. So the communication channel may be the fiber, the cable, or the satellite. Obviously, the internet is one of the example of the communication channel. So that is distributed system. So when we design an application, a distributed system, what do we care? So what is something in our mind that we should think about when we design that system? So the CAP theorem is some sort of like the basic principle when we started working on this distributed system. So it's in the system, we have some sort of like consistency, availability, and the partition tolerance. So consistency means, so we have 4 nodes on the screen right there. So it's if we write on the node number 1, let's say we do a write, and then we do a read on another node, let's say node number 2. So the consistency say whatever you write on node number 1, and then when you read it in node number 2, the data that you read will be not the old data. That's what consistency means. It doesn't mean that you will read whatever you just write, but it means you read the latest data in node number 2. For example, in node number 1, you write the number 1000. And then when you make a query on node number 2, let's imagine a node is a laptop, is a client, right? And then you query on a server. So you query on that node. You make an update on that node, and then you query on another node. Then when at the time you make a query, whatever the data you got is the latest data. It doesn't mean that the one is the one that you just wrote, because maybe there is another guy just updated on node number 1. So it makes sure the consistency means you don't get your own data. The availability promise means if you're trying to access a node, which is not, obviously it's not a shutdown node. It's got to be like function. Then you gotta get a response, which means availability, right? So if you try to access a house, then obviously if the house is not destroyed, if the house is available, then you will be able to get into it. So then that's basically the availability. So the partition tolerance mean the partition tolerance, like it related to the network. So if the connection between like number 1 and number 2 is disconnected, then how is the distributed system like react? How is the data between like being synchronized between those node 1 and node 2? So that is the partition tolerance. The CAP theorem say in this distributed system we only have maximum 2 promises at the same time. We cannot get all of them. That's, the scientists or the researcher, they prove it. So here we learn it. So in relational database, in our environment, 3 of them, when we develop an application, maybe we got CA, and we say, hey, the partition tolerance is something non-negotiable. So we focus on CA, or we focus on CP or AP. 2 of them when you design an application. So that's the goal of the CAP theorem. We understand it, and then we set the goal. Okay, this application I'm going to design will be satisfied this and this, or this and this, or this and this. So by setting the correct goal at the beginning, we don't get confused down the road. Like when we deploy an application, like a year from that, we got an issue, and then we don't know how to fix an issue, then it will be like nightmare. Here's the proof of the CAP theorem. So we have 2 nodes, node number 1 and node number 2. Right now, there's a middle line there. It's not connected to each other. So this is a partition. Now, when we write something to node number 1 and we read something from node number 2, what do we get? What will the option that we have? When we write something in node number 1 and we read something from node number 2 in the distributed system. 1 and 2 are in the same distributed system. So there are some the first case is, when we write to number 1, node number 1, we're trying to sync to node number 2, right? Either like the pushing or the pulling from node number 2, but they cannot communicate to each other. So then when we read to number 2, what we got? We got our own data, right? Because the data that we just write is not going to number 2 yet. There's no way. There's the partition is there. So the first option, we will get our own data, which means it's not consistency. Now, when we design an application, do we want that or not? That's the question that we need to think. Do we want to get our own data? Do we allow the dirty data? Now, the option number 2 is when we're trying to read the data from number 2, we will make the user like waiting. wait, and timeout, and error. By that, we're trying to accomplish the consistency, because we don't give the user the dirty data. So we say, hey, you are reading data from node number 2. Let me try to get the latest data from node number 1. And then it's trying to make a connection or whatever, then it couldn't get it. During that time, it will get a user waiting and eventually time out in this case. So in that situation, we're trying to accomplish the consistency. And then, we forfeit the availability because the user is waiting and then eventually couldn't get it. So that is the two things that the CAP theorem is telling us. Now, in our relational database, what is our choice? We know that, our choice is depend on what application you are writing, you are designing. For example, if you are designing like a statistics application, like something, give me the amount of data, right? And then in that, you don't care about the latest data. Just give me whatever you have. So if that application is trying to do that, then okay, you forfeit the whatever consistency. So when a user make a read on node number 2, you return whatever you have with that application. What about some other application that you need the latest data? For example, like in banking, right? When you want to, transfer some sort of money, then you want to have the latest, the balance, the latest balance amount of data in order to make the correct transfer. So in that case, you want to have the consistency of your data, especially that money. It's got to be consistency. So if the user couldn't get it, yes, let him wait, or even like timeout, return error. Then he'll come back and get it later. So depend on the goal of the application, you will say, okay, I'll forfeit this to get this, or I forfeit this to get this. Some fallacies, as a developers, we tend to make some mistakes when we designing the distributed system. The first one will be the network is reliable. How many of us here think that the network will be reliable in your application?
The code assumes it will be.
Okay. Well, it gotta be like the network is down, like it's not like permanently down, but then it temporarily down is like all the time. So I can tell suddenly something happened, then it's down, some accident, some like the cable is disconnected, or the cable is like, whatever the device is broken, or some accident, some storm out there that break the cable, the fiber. So latency is 0. So object-oriented programming is different than network programming, because in two objects in the same machine, when you call like, hey, update me something or give me something in the object programming, it will return you right away. It's just the milliseconds of your processor on the RAM, right? How fast your computer is. But in network programming, it takes time to send a request to the server or do something, and then get a response. So, every time you do, you got to think about the timeout, or like how long you will get it. Or you send a request, and then what you do if you don't get a response? Will you wait, or will you cancel your request? So the latency in network programming is not 0. Bandwidth is infinite. It's not. The bandwidth is important. If you enroll like the CenturyLink internet, a 12 megabyte package will cost you like $29 a month. But if you enroll like 1 gigabyte package, it will be like more money, right? So there is a certain amount of bandwidth, and then there's a cost for that. So when we develop the network programming, think about the bandwidth. It's not like infinite. It's limited. network is secure. So here's another fair assumption that network is secure. We know about hacker, right? Hacking. Even internal network, intranet. When you develop a distributed system which is intranet, and we think, hey, this is just our company. We have like 1,000 retail offices across the country. So what they are belong to our company, they are not gonna hack it. So this is fair because, I mean, most of the attack is happening from internal. Topology does not change. So we assume that, I mean, the way to communicate between the server, between the nodes are the same, and it's never being changed. So that is a fair assumption too. So we gotta be ready for the communication methods is changing. So by that, we will design the system in a way that it's configurable. So how is the way that this node communicate with another node? So it got to be like configurable and dynamic. There is one administrator. Yes, when you are developing your application, you are the administrator. But then when you get to the system test environment, maybe you're not administrator anymore. Or how about like integrated or production? There'll be another team to manage that. And that team may have multiple administrators who access to your server. And then even those administrators may have some knowledge about your application or maybe not at all. So even like in cloud computing, in cloud, right? They don't know what is it, so they just assume this is something that's running. So if we assume that they know what they're doing, and then we just think, okay, they may know as we know because this is my application. I know how to do this. They should know that. Then maybe that's the failing assumption. Transport cost is 0. Yeah, it's not. So every time the message sending from the node A to node B, this is not free message. If you text from my cell phone to another cell phone, this is not free. I got to pay for that. Like somebody got to like maintain the connectivities, the facilities, and then, I mean, this is not free at all. Network is homogeneous. When you develop the first version, yes, the first deploy, yes, it's true. But when the version 2 happen, you deploy version 3, version 4, and then there's an issue. Happen. Then you got to track down, hey, what this version is doing, what is this deployment doing, and then you got to run back. So at that time, the network is not homogeneous at all. So if we design a system that we assume that network is homogeneous, and then we don't prepare for the later on with the fair assumption, then we may not know how to fix the problem down the line when the production issue happens. Now, if we review the CAP theorem and the fallacies, so on the left, we have pre-CAP. On the right, we have like a list of fallacies there. Now, if you look at the first one, network is not reliable. And then here we say partition tolerance, which means this one is not negotiable. The partition tolerance is not negotiable when you design your distributed system, because network is not reliable. It will be down. It will be down at some point. So what if you transfer the money, right? You pay the credit card, and then you go. Let's say you go to Walmart. You have the gift card, right? And then you have $100 loaded, and then you check out something, and then at the moment you check out, then you swipe the card, right? What will happen? The card reader will read your ID, read the card ID, and then send back to the central server, and then they subtract your amount, right? Let's say you got $100 there, and then you check out $30. Then you're supposed to have $70 back, right? Now, what if I mean, you swipe the card, it's go all the way down to the server, subtract your $30, right? And then it send the confirmation message back to the machine, right? To the card reader, and say approve, right? What if during that the way it go back, it's fail. So it's fail. It means on the screen it say, hey, fail, right? It failed, but I mean your balance was deducted at the server already. Now you have only $70. Then when it failed, then the cashier will ask you like, do what? Check again, right? I mean, if you don't swipe it again, how can you check it out? Swipe one more time. Then okay, go all the way back to the server, and then it returns successfully. Okay, now you check it out and you go home and then check the balance. Say, why I only have $40 here? Something wrong, right? And then now you call what? You call who? You call Walmart or you call the store, right? Hey, what happened? Then they say, guys, I don't know. I mean, I check in your database and I see there's a balance. Say here's your balance is $40. So this is your balance. Clearly, I can take a picture and send to you. This is proof. This is the balance in your card. So they say, what? No, that's wrong. But then you do what? If you are the person on the phone, then what do you do to explain it to him, to me, right? Hey, this database saying so. It's what it is, right? This network is not reliable. Now, because of that, when you design an application, you got to work on the C and the A. The P is not negotiable because it will happen, and we know it will happen. We cannot control it as a developer. So this is hardware issue. It may happen anytime, anywhere. So you got to be ready for that, and this is not negotiable. By knowing that, we will focus on consistency and availability when we design distributed system. This is, so when we focus on the two things, the C and the A, either application, as I mentioned at the beginning, we can either forfeit consistency or forfeit availability, depend on what kind of application you are designing. Is it a statistics application, or is it like a banking application? Or, I mean, it's up to depend on the application. So you got to make a decision on this. Partition tolerance is not negotiable. Now, before I move forward, any other questions so far? If you have question or disagree with me or concern, just raise a hand and interrupt me anytime. Okay. Now I'm going to review some design problems and the solution of it. First of all, it is CQRS. It is like command query responsibility segregation. Basically, this is a pattern. It is not an architect. It is not a principal. It is the pattern. And what is the pattern? What is the design pattern? It's basically like an experience of somebody. They face issues, and then they work on it. They document it, and they say, hey, here's what we learned. So it becomes a pattern. Again, I mean, following the pattern is not really like always good. Sometimes it's not. So I've been in like developing an application where like a team, we always like looking for some kind of patterns, and then everything is pattern, and then at some point we say, hey, there's so much pattern in our applications. And every time, I mean, the new guys coming, like we hire a new team member, then that's a lot of pattern I need to follow. So if I want to add a new column in the database, so here's the pattern that you need to do. You need to go that, you got to do that, and then that's done. Say, what? I don't understand. So pattern is good, but we got to be like careful when we choose a pattern. Or that's why we have some theory about anti-patterns is also good. So be careful on that. CQRS is a good pattern so far that have learned. What is the problem that CQRS solves? So it's basically the command and the query segregation. And what does it mean? Let's think about you develop an application where you have a lot of users interacting at the same time with a shared amount of data. For example, when you book an airplane to go to vacation somewhere, you go and book an airplane, right? You go to United Airlines, booking, check out, done, right? Then you select the seat reservation. So there are multiple choices. You want to do the window or the aisles, or if you have like the 3 members in your family, you want to book like the next to each other, right? So that application, apparently when you pick that seat, there is another guy at the same time, picking that seat too. And then if you click on confirm and that guy click confirm, then what happened? Can anybody tell me what happened?
Most likely customer service has to get involved.
I think that's a good answer. Yeah.
Only one guy gets it. First one in. The back end will have a locking mechanism, and then you will fail on the second person to do
What
it.
if they do it at the same time?
Yeah.
Give a solution.
Yeah. So, yeah, we got a good answers, like customer service get involved, right? And that's true actually. So, when you reserve the seat, right? And then you take the ticket and you go to the airport. Hey, I booked this, and then at that time the representative say, hey, sorry, you don't get it. You got this, right? Then she negotiate with you. Then, hey, no, I got this. This is my confirmation. You got to discount me like 50%. Okay, that's one way. Now, when we design those applications, what is our options, right? So maybe it depends on the business rules, what the business owner want to do, or when I work at like the other gentleman say, maybe the first person win. The one who get in first win, and the second well, what about, the safe chain, right? In the data contact, you do safe chains. It pass on of the check, and then it go there, and then it's hit safe chain at the same time. Then it's random. I don't know. So when I work on at the Farm Credit Service of America, we have similar issues where the finance officer, they have multiple finance officers, and they work on the same balance sheet of the same data of same customer. Now, their solution is, our solution is, the business owner solution. They tell us what to do, right? So their solution is, if the financial officer open that balance sheet, and then is about to work on that data, and then, the system will detect who is on that balance sheet at the same time. So if you open the account of the customer A, right, and then you are on that, then another financial officer open that customer as well, then we'll do like kind of a signal R, like a polling system, and it's showing my face in there. Say, hey, Tom is on that customer right now, and then it will pick up the phone, or they have an internal messaging system. Yeah, chat, hey, what's up? What are you doing there? Can you get out of that? I want to update something. So this is like the human, get into the process.
So that's a locking scenario. Lock your record, nobody else can change.
Yes. Yep. That's another solution that we lock it. But in our case, we don't lock it. But it's business owner option. We don't lock it, but we show the face. Say, hey, you are there. Now, in airline reservation number, we don't know. I don't know you. You and I go in there, and then me and the guy in China and booking the same time, or me and the guy in Washington D.C. Right? I don't know who is doing that. Now the option is the CQRS design pattern will solve that issue. Basically, when you click like reserve, what happens is you will get an email confirmation. Hey, congratulations, you successfully place a reserve your seat, right? That's what you get. Now, I mean, inside the application, what it does is it plays your commands. I mean, the reserve is the commands. It's play that in a message queue, in a queue. How to implement that message queue is another step. But basically, there is the middle guy, the middle process who receives your commands, and then at the same time, Matt will place another idea and another reservation. Then okay, congratulations, you successfully placed the reservation. Here's the confirmation number, whatever, to prove that you placed the command, right? And then that middle process will, sequentially go to the system and then update database, because that guy will handle the things, who come first and who come next. So by doing that, this is the command. The command. So when you place an order, you don't get back immediately the feedback. Instead, you get an email, confirm it. Hey, you're done. Then we will let you know later if your order is successfully or not. So that is the command. And then when you want to know the status of your reservation, you make a query to the system. Hey, give me the status of that. I have the number here. And when you got an email, right, you got a confirmation number for your commands. So we have a command. You have a command number. Then you can make a query to the system, say, what is the status of my reservation? Then it will tell you. So command and query is separation. Is separate now. That is the solution to solve the problem where multiple users to work on the share amount of data. Here you place an order, and then that little process will be a command process. And one of the ways to implement that is message queue is the simplest way to do. And but there will be something to think about when we implement this. So what if? There is an error back, right? There is a confirmation back. Say maybe this is an email. Say, hey, you successfully placed an order. What if that message gets lost? Network is not reliable. So you place the order, and then you don't receive email. You don't get the confirmation back. Then you place another order. You click again and again, but it gets lost, and you click 10 times. Now that's one issue. The second issue is when you process the order, right? Basically, you go database, you update the seat number. This is for Matt, seat number 1 on the window. Then when you process, will you delete the commands in the queue? Maybe yes or maybe no, because you send the process order there. What if the return is lost? Usually, when you process, it will confirm, hey, you're done, return okay, return true, right? But what if return is lost because the database may be down, network? Or there's some issue there that the return is lost. But then if you delete a command already, then you lost a command, you lost a customer. Now, that is some durability issues. So we have some issue there. We got to take care of why we design this system. A, the duplicate message. B, the loss of the order, the loss of the commands in the queue. So that's something we need to be careful. Here I got some scaling steps. So this is the client connect to the server, and then the web server will connect to the database. Now we introduce the commands process there to separate the on the right will be the command, and on the left will be the query. Now if we put more clients, and then the query seem to be like overloaded. So it will be a lot of queries. Now, so obviously we add more server. Every server we do like command query separately like that. Then still there is one last step will be, we make all of the commands into a separate server, like a processing center. And then the rest will be just for query. Because I think the scalability of the commands is harder than the queries. Because, in order to scale the command, you got to do like parallel, or you got to do like asynchronous, or you got to do some fancy technique. But in order to scale the query, you may just simply add up the server in the web farm. And it seems to be like easier to scale the query. Or, you can write a better add the index or whatever, right? So scale the command seems to be harder. So that's why the suggest architect will be like put the commands in a separate server and then add more RAM on it. Add more RAM, add like some, 1,000 of gigabyte there, and improve the algorithm to, parallel, adding dual core, whatever, like multiple core supercomputer to command to process it. So
another thing you might be able to do is have like 2 servers handling the commands depending on like whether the flight number is even or odd. So in your example of flights, as long as they're handling different flights, one flight belongs to a specific server.
yes.
Then that would be a different way to scale it.
Yes, so if we add another server to process the command, that's a good idea, because we may have, what if like one server is down, right? Then we still have the redundant server to still process the command, and it's like backup reverse. It's just like synchronize each other, right? That's a good point. Now, with this design, and back to the CAP theorem, what is this design leaning forward to? Is it leaning to availability, or is it leaning to consistency? Availability, right? Yes, because when you do a query, you always get it, and the commands is just like keep processing. So to put the latest data to the server. So whatever you query, you will get it right away. So make sure it's leaning toward availability. Okay, so CQRS, that finished the CQRS section. Any questions so far? Cool. Now we move next to when people talk about CQRS, they only like talk about event sourcing, and it makes me think like what really event sourcing is, and is it important to know or not, or I just don't care. So let's think about like the shopping cart application. So you have a shopping cart, and there are 2 ways of designing the system. On the left, you have multiple events. When you create an object, right? When you design the system, let's say when you design a system that allow the people like check out and add the product to the cart and then check out, right? So what's in your mind? What is the process of, how do you design it? Is it like, okay, create an object, like on the right? Create the objects, and then there is available like a list of products that you added to the cart, and then you have, when you hit next, you'll be like, enter your credit card application, then you hit next, you enter like shipping address, right? And then you hit next, you check out, you're done. And you get a confirmation email. I worked on that application before, so I know exactly that's the process. Even the shipping address, you have a checkbox say, hey, the shipping address is the same as the billing address in the credit card. And then even you can choose the payment method. Is it a PayPal, credit card, or whatever? It will be. So this is the typical structure representation design. Now, the application is deployed successfully, working for years. It makes a tons of benefits to the company. One day, the vice president of marketing comes to your team and say, hey, I want to know what are the products of a user named Matt, where he removed from his shopping cart in the last year, when he went to shop, right? When he will go to the website, and he goes shopping there. In the last 5 minutes before he check out, I want to know what is he's removing. Why he asked that question? It's a common sense when I go to shopping, right? When I add it, and then I check out, I say, no, that's too much. That's like $1,000. I mean, it's out of my budget, and my wife may complain me on that. So I gotta like delete something. So in the last 5 minutes, I delete something. So those products, it doesn't mean I don't want it, right? I like it, but I don't want to buy it now because of whatever reason, my budget is short or something. So the vice president of marketing want to know those information. How do you answer them? Say, no, we don't have it. We lost those information. We don't care. This is really important because if you design an application where, okay, Matt, go in there, add the first item, add the second item, add the payment info, update item, and then remove item number 1 on the left side here. When he removes that, if your application can catch it and then say, hey, Matt he wants this product, which is like value like 12,000, but why he remove it? Let's keep here, and then let's keep like sending him an email. Say, hey, Matt, there's a promotion on that item. So it was 12,000 2 days ago, but now it's like 8,000 now. You want to buy it? So if the application can detect that and then send him an email or update him the status of that product, because clearly he's showing his interest in that product. So that's sort of like the power of event sourcing, where we keep track all of the events happening in your application, all of the commands. So in this case, these are the remove commands. And when we talk about event sourcing, it's really a design that allows us to construct the state of an application at a certain amount of time. For example, if we want to know, okay, what is the state of the application yesterday, then by some query or by some going to the history of the events, we can exactly like reconstruct the status of that application. So we keep track the history of it. So this is really what is event sourcing is. What are other domains of this application? This kind of like pattern is useful. So let's think about in financial application, your balance, your checking account balance. So do you think that if you open your account, right, you see the balance is like 100,000? Do you think that is it a column in database that contain that 100,000? That number? Who thinks so? Raise your hand. So the question is, if you open your account, your checking account, you see the balance is like 100,000. Who think that there is a column in database that contain that 100,000? Who thinks so? Raise the hand.
Like a row in a column?
A column would
Contains that information.
would have that 100,000 number. Okay, now the question is, where is that 100,000 number coming from? So how do you design the checking account feature to show that balance to your customer?
Aggregate transactions.
Yes, that's one of the good ideas, and I believe that the banking system, they do that. So it will show like, okay, you open an account, so you do initial deposit like Okay, 1,000. It was okay, 1,000 is there, and then when you add more, so it is okay. This is 1,000, and then the balance is 1,000. When you get a salary, right? So the paycheck coming with like 10,000. So okay, another line 10,000. Then the balance will be like 11,000, and then you spend just like 9,000 to buy the TV, right? So it will be another like minus 9,000. So your balance will be like 1,000. It's really the aggregation, the equation, the sum of those transactions to show the value, right? By that, right? If someday your customer call you and say, "Hey, dude, I think my balance should be like 300,000. Why? How come is it only like 9,000?" Then you gotta tell them, "Hey, dude, this is your initial deposit on that day, and then on that day you do that, on that day you do that. So your balance should be this." If you don't have those history, you basically you cannot explain to your customer, and then you gotta give him like 300,000, right? Because you cannot explain.
You know,
So.
you know, yeah.
So this is credit card application, which is interesting, right?
Okay.
Now, what are other like domains that the event sourcing? I mean, when we talk about event sourcing, we are keeping the history of the status of your application. How about like the law industry? So when you talk to the attorney, right, or when you sign something with your company, let's say you sign a contract with your company, and then I'm signing something with the tax system, and yeah, Tom, we do something this, and a year later, somebody in tax system like clear something that we sign, and they delete some line there. Is it allowing doing that, right? No, the industry doesn't do that, because by clearing something, you are deleting the data, and deleting data is not good. So in legal industry, what they do is, if you want to change something, you make an addendum on top of it. Say, hey, whatever the agreement we have, okay, here's the addendum. It will sit on top of that. So basically, what is it meaning there? It means you are appending something into your system. You are not updating or you are not deleting. So, there's another applicable of the CQRS event sourcing there. So by appending thing here, you are keeping the history. And by saying keeping the history, actually, this is events. So everything like an addendum enter is an event. And then you're keeping the stack of the status, the history status. So you can go back and say, yes, at that time, Tom signed this, but now he got something like on top of that. It's legal industry. So we can apply that in legal, some application. Now, how about healthcare? So when you go see your doctor, and then you have a new, he take a new picture of you. So is he or she like delete their own picture and then override it? I don't think he would do that, because, like last year, your pictures look different. This year, much younger, right? So this year is more handsome. So I want to keep that. So if he just go ahead and delete the previous picture, it'll be like, how do I look like before the treatment, and how do I look like after the treatment? So we need to keep the history. So in healthcare, similarly, we append the data to keep the history. It's not like just edit and go delete it. So these are some, healthcare, finance, whatever, like e-commerce. Those big industry, right? I bet we can like list more areas that we can apply event sourcing.
So Tom, when you're talking about the aggregation, I think I definitely see the value there. The first question that comes to my mind, I think I might have an answer here, but I'm curious to hear what yours would be. Doesn't that cause a performance issue as opposed to just updating a field and having to read it? And if, let's say you had 100,000 transactions, now you have to aggregate 100,000 transactions to get the current balance. Doesn't that cause a performance issue?
It's a good question, because in the event sourcing system, the performance is always a good question to be like asking all the time. And they got a solution of that by implement something called like snapshot. So, I mean, at some certain time, we make a snapshot of that, and then when you query from the current state to the go back to the history, when you meet the snapshot, we just like load it. So snapshot is the solution to answer the question about the performance when we query the events in the system. But then snapshot is, there is the downside of that as well, where, I mean, we gotta be careful. So snapshot is the answer, but when you do snapshot, what about, I mean, you make a snapshot of version 2, and then now we deploy some newer version, like version 3 and version 5, then, okay, you go there, and then which, maybe in the version 5, the business rule is changing and some sort of event is changing. So, I mean, you may need to have the connection or like migration to the newer version, and migration may be the pain. So, but I mean, that's doable, and that's the solution to, is it answer your question?
Yeah, that's
Okay.
mostly more data warehousing, but of course it works too.
The other problem is, what if the rules change and you start building inaccurate snapshots of the past because you're applying new rules to the old data? So you would need to take a new snapshot at the time you convert to the new business rules, probably.
Yeah,
There would be things to figure out.
Yep. That's a very good point. And yeah, I mean, some other benefit of event sourcing is, let's think about the that is the, what is it, the security. So in the security of your application, what if somebody, let's say in the horse racing application, when you bet, right? You bet this horse is win or the other horse is win, right? And then somebody in the administrator, trying to hack to your system, and pick the right horse, and then if it raises some suspects, then how do you prove that this result? This is the hack to cancel his. Obviously this is like $100 million win. So if he pick the right combination of the horse who win, right? There will be multiple rounds. And then if he pick, okay, first round of horse number 4 win, second round will be number 3, third round will be number 4. If he pick the correct combination, he'll win the bet, right? The race. Then, well, if somebody like hacked into the system, which maybe the administrator he knows, then we should be able to go back on up the events, on up the history of the application to prove that this is not the correct. This is a hack. So security is something this design is supporting good. Next will be enterprise service bus. This is very common topic where, so in distributed system, SOA, service-oriented architect, is very common. And so those nodes is communicating each other by, sending messages, right, obviously, but then the way they're sending messages is like the let's say XML. So we one of the pattern is we make it as a service to talk to each other. And the service, if we have like 5 nodes here, then how many endpoint, how many API we need to define for like a node to talk to other 4? And what about, we have 10 nodes in the system, and then every node will have defined with the way to talk with other 9 nodes. And it will be like a nightmare. It's really hard to maintain it. Really hard to know like who talking to who, and then how many messages is sending a day, right? And what are they talking about? So at Farm Credit, I work on an application with a partner, and we expose our API with them, right? So initially they we sign a contract, and then we expose the API each other, and then we call into their system, and then they call to our system. At some point, the management come down and say, how is you guys doing? How many messages? How is the communication of our application with the application? And we don't know. They call us, we call them, but nobody keep track the interactions. So then, at that time, we thought about, okay, enterprise service bus, maybe what we need to stay in the middle and then define a single contract, define a single API to interact with with each server, and then to modify it to whatever control the flow, and then log the data, and then maybe write something statistic data there to answer the question, to manage all of those communication. So enterprise service bus is basically the middleman who control the communications among nodes, among many nodes in SOA distributed system. Next slide, we have some feature. There are two kinds of, this is just for documentation. There are two kinds of ESB broker and decentralized. The broker, we have some big player in the market like TIBCO, BizTalk, and WebSphere. Similarity over there, we have N-Service Bus, Mass Transit. So depend on the need of your application, the nature of your application, you can pick either one of them. So they have the single point of config, single governance body, middleware, some make some decisions. Over there is contract. So these are the key feature, the key difference of those two kinds, and it's really a product we can buy. It's a big topic from either one of the player there, one of the provider. I think at Farm Credit we're using BizTalk. So just configure the endpoint here and there. Well, some feature of ESB will be, security. It added another layer on security. For example, when we want this service talking to another service of a partner, right? It's outside of the company. Then okay, what is the credential? Okay, who can be allowed to? What kind of credential we agree upon between us to talk over the ESB? It's forwarding, it's routing the message, it transfer the data. So the ESB can add some information that even the service is not provided, maybe like the daytime, right? So we send a message, but in the ESB, it can add the daytime to the time that the message is being sent. And then it can do some massage of the message to log to their own database somewhere for auditing purposes. So those are basic feature of ESB. It's basically a relay component, relay message component to manage the communication. It makes it easier to manage. The last pattern is publisher subscriber pattern. It's solved the problem where there is a publisher who wants to send a message to many subscribers, which they don't need to know who is receiving it. It's just like broadcast the message. And then the subscriber who subscribes to that kind of message will get it. For example, if you go to YouTube, and if you open a video, right, and then you like the video, and then there is a little button there that says subscribe to that guy. So what it means is when we subscribe to that, so what it means is whenever the guy has some new video, it will show up on your dashboard. So you will get it. Another example is Twitter, right? So when you follow somebody there, and then if you tweet something, then you will automatically get it. So this is public subscriber, applicable. Now, the publisher subscriber, it solves the problem of the tight coupling between the sender and the receiver, right? The sender doesn't have to know doesn't create a receiver one object, receiver two object, and then okay, send there and then doing anything. It just broadcast, and then it lose coupling between the sender and the receiver. Now, yeah, that is the basic diagram about the publisher. Well, the components of the PubSub pattern is the publisher, and then there is the sort of like event, or the relays, the place where we configure the topic or the event. And then there will be a subscriber. So there will be 3 players there on the screen. So basically the publisher, they will say, okay, I want to publish an event like touchdown. In football, right, there's a touchdown. So if you are as a subscriber, you subscribe to that touchdown event. Then every time there's a touchdown happening somewhere in the match, then it will send you the video or send you the link. And then another case, they publish another event like .NET user group. Okay, so somebody subscribes to .NET user group. Then when Matt publish something on that event, so all of us who subscribe to that event will receive the hello work from Matt. So that's basically the pattern. One application of that is in smartphone. When the battery is low, right? When the battery of your smartphone is low, it needs to send the message to the application, say, hey, the battery is low. So how do we do that? We can implement this to publish the battery status to the to the battery status event, right? And then when it's low, then the system will publish the information to that event. And then the application, in smartphone, we have a lot of application, who knows? So what application does is just subscribe to that. Because as a developer, when we develop the application on a smartphone, we know that the system will have those events, right? Because batteries is something like basic, and we should know it in the SDK. We should know those events. So we just recognize in our application, okay, there's an event here, so we got to do something. We got to run faster or whatever. it's going to die. So that's another example of PubSub. I would take about maybe 5-10 minutes to demo the PubSub in AngularJS. It's interesting that I have learned these days. AngularJS, we can do something like this. So who in here has used to work with AngularJS? Wow, we got a good amount of audience here. So cool. So AngularJS is a JavaScript framework invented by Google team. And it's purely like client-side framework, JavaScript. So the way that they do is they have a $ root scope. They have a hierarchy of the scope. So they have a root scope, and then scope 1, scope 2, whatever. They have inherited like a big a tree, a hierarchy tree. Now, with that facility, it's really good for something like PubSub, because the problem I raised here is how, like on the screen, right? How the scope number 1 can communicate with scope number 2. Can somebody answer me?
Through the root scope. Sending a message to the root scope.
Yes, send a message through root scope, and then root scope will broadcast that. Because obviously there's a link there, right? So this is a good hint. Now there is another solution that if we use the service. So the service may be something like share data, all right? Or when we talk about service, we can talk. What about I save something from scope 1 to database, and scope 2 will read that from database. It's also the way to communicate it, right? So, but obviously, communicate directly through root scope may be the fastest and easiest way to do. So by that, I have a little application that that's showing us how to do that using, like we went, so basically, let's say scope number 1, we have an event. An event, maybe something like, hey, I updated something. So in scope number 1, I say, update something to database, do something, and I get a return back. So I want to publish that event, say, hey, I'm done. Now, let's say scope number 2, want to take the result from that message, from that work, right? Because the scope number 1, obviously he may generate something. And scope number 2 want to take his work and doing something else. So then the way to do is scope number 1, when he's done, he published the message to the root scope. He say, yeah, I'm done. And then the scope number 2 will subscribe to the root scope to say, hey, whenever scope number 1 is done, like subscribe to the event like done, scope 1 done, right? And then he will get it when the scope number 1 is done. He will get it and he will do, okay, do this. So that's the idea. Now, this is the service bus service. Let's double click on that. Okay, double click on that. What is it? This is the route, no, not route. Okay, here. Service bus service. Can I open that? Oh, where is it? Oh, it's showing on my screen. How do I move? Okay, I got it. Yep. So this is the service bus service. So basically, what it's doing here is it's using decorator pattern. Decorator here in Angular, basically it modify the root scope behavior. It's adding 2 functions to the root scope. The first function is the publish. So as you can see, this is root scope.publish. This is the newly user-defined function. And this is the subscribe function. This is the user-defined function. And in order to do that, I need to do decorator function here. What is Angular syntax? They provided us to modify the behavior of that thing. And this thing right now is root scope. I want to add 2 more functions into root scope. One is publish and the other one is subscribe. Basically, this is the dollar delegate here is the service, which is the syntax of AngularJS. I need to do that. And here, delegate here is the representation. It's kind of a representation of the object of the service being defined here. In this case, this is root scope. So here I assign it back to root scope, and then in the publish, I say emit. In dollar, the service emit basically pop up everything from where you are. So let's say you are scope number 1 and you say publish. So it will emit the event all the way up to the root scope. So the argument here is whatever the events that you define. So this line basically saying, okay, I'm going to register the event at the root scope level. It will emit all the way up to root scope. Now in the subscribe, there's a dollar on here. So really the emit here and the dollar on here is the key. When the subscribe happen, they say, hey, something happened at the root scope level. If something happened on the root scope with the arguments here, which contain the event that I will define, it will be just a string. Then we do whatever the function that's a way to find the event. And then after that, this here means the current context. So if I'm in scope number 1 and I subscribe to, in this case, I'm scope number 2, and subscribe to that event, and when scope number 2 is gone, maybe the user close the page, then it will destroy that that event, that function. Now, let's run it. Here, so this is just a way to implement the publish and subscriber. Then, let's say I have the place order in the main controller. So in my demo here, I have four controllers. One is the index controller. The index controller basically it's a it's an update something. It's a, okay, it define the method like update something. It will go all the way back to database and generate me. What it does is it generates me a number, a confirmation number. So when the confirmation number is back, this is data. When the data is back, I will take the value and I show the confirmation number on the screen. And then I publish this one. This is the update finish. I say, hey, update finish is the name of an event that I define right now. So whoever wants to know the event, the update finish is done, then you need to subscribe to that event. And then this is the data that I want to pass. So whoever subscribes to that will have that. Now, I have subscriber controller here. It say, hey, I want to subscribe to that event, the same name, the same event. And then with the data there, what it does here is very simple. I get a value, I add it one. That's it. I may do something else, but for the demo purpose, I just added one. Now, another controller, I say, okay, subscribe to that event, and I add it two. And the last controller here, I say, yeah, still subscribe to that, and then I add three. So every event or controller, if it want to get the result from the index controller, it will just subscribe to that event and get it, and then do whatever it want to do. Now, on the index page here, obviously, this is the index controller where I can place an order. When I click that, I will get a confirmation number back. In the subscribe controller, the first one, I will show, I show the same value plus one, because in the implementation I plus one. In the second controller, it will be plus two. In the last one, it will be plus three. And obviously, those are different controllers in the code. And this is it's living in different file in here. Like here is different, is different. Now let's see if it works. So I place order. Yep, I got a value 736. The one here I plus 1, 7. Here I plus 2. And here I plus 3. So clearly when I got a number, it will publish to all of the audience who is subscribing, and the audience get it, and then we do whatever. It take the work from the publisher and it do something, or it may not take whatever at all. It may do, hey, I know you're done, so hey, I arrived at destination. Okay, when you arrive, then publish me that you are there, and I'll start running. So interesting thing here. I thought it would be fun that the subscriber tree here. It may have an option like unsubscribing. So I said, hey, I don't want to, it's too much. You send me a lot of spam emails. I don't want to take your information anymore. I hate you now. I like you at the beginning, but now I don't like it anymore. So unsubscribe it. So now I got, 36 here. So I do unsubscribe. I click on that. Now if I place order, those subscriber 1 and 2 keep receiving it, but then subscriber 3 no longer get update. Or, at some point I say, hey, I miss you, let's resubscribe it. So I click on that, then I keep getting the new events. And let's look at how I implement this unsubscribe and resubscribe. The idea is very simple. I make a two function, and then it say, hey, if you are subscribed, then unsubscribe, and then initially when it's loaded, then we run a subscribe. And then when you click unsubscribe, then it is when you subscribe again, it do that. So, I mean, this is kind of like a pops up in the client side with AngularJS.
So when you emit those events to the root scope, does it pass the data by reference, or does it serialize and send it through event, so it's a new instance for each subscriber?
It's, so the data here, right? So you said the data here is passing by the reference.
Does it pass, so if you send an object, do all the subscribers get the same instance of that object, or does it use like a window event to serialize it and send the data out? So does it end up being a new instance for each subscriber, or do they all share the same instance?
Yeah, that's going to be a clear documentation.
Yeah, it's a very good question. I mean, I'm not sure. Yeah, I don't know. Yeah, we gotta check that, and yeah, like, we need to check Angular.
I was curious, we're doing something very similar, but rather than through root scope, we built a messaging service that is all pub sub, and then we give the option to send by reference or send as a copy. So it will actually, Angular will actually copy the object if you're not sending by reference, and then the subscriber will get their own copy of the data so they can shop on each other.
Okay. Now, there is another way to implement this concept, like you said, right? But then, are you using web broadcast? Or?
We're not using any Angular stuff at all. We built a complete service that handles the subscribers and the publishers.
Okay. Yeah, so in Angular, there is another way of doing that, which I'm not suggesting doing that, which is using broadcast. So in this case, let's go back to the screen here. There is another way, like, based on the rules. So we started from the root, and then we say, hey, broadcast everything to all of the guys that something is happening. And then when the child is subscribing with that, then it will, it will catch the event. So what is not is the suggested solution to do, because the broadcast, is the performance hit. So the image seems to get better. So we discussed about it, and we think the image is better. But I gotta check document on like, is it a reference or is it a real copy of it?
We went with the peer service route because it gives us the choice, and then we can also send synchronous or asynchronous. So if we want the messages to send at the end of the stack, we can use it as the timeout service to send them at the end of the stack rather than immediately on the subscription.
Yep. Well, actually, when you remind me about the timeout, this is one of the problems that we need to be aware when you do a pop set. Because what if the subscriber is not receiving the message from the publisher? Then what do we do? How do we debug? And that is one of our problems right now. But we say we trust AngularJS, but we got an issue where the other implementation like the broadcast thing, it gives us the option to specify the time. And then when something is not expecting happen, they say, let's increase the timeout like from 1 second to like 3 seconds, and it works. And that's scary. So that's a motivation for us to look for the alternative solution with the image. Seems to be better. Still knocking on the wood, but we're still learning AngularJS stuff. Yep, this is the reference file I learned from those people. This is the end of my presentation. Any other questions? Thank you much for attending.
I did have one more, just as another alternative. We talked about pubs up, but as far as handling the messages, there is one more option, and that's the queuing option, where the first subscriber just peels it off the queue. Whoever grabs the message first, will be able to take their profit.
Okay, so the publisher user will publish a message into the queue.
So, not for the pub stuff, but we're talking about,
Service pubs, the pubs.
yeah, yeah,
Kind of thing.
yeah,
Or the command query.
sure.
The command processor.
You can have queues with multiple processors, each doing a load of work, and when it's finished, whichever one finishes, it grabs the next message off the queue, and then the next one grabs the next message. But each message only goes to whoever grabs it, it doesn't go out to all subscribers.
Oh, but by that, you need to know the receiver.
Just have to know that the message was taken off the queue or
The receiver takes the message out.
Okay, and then when the receiver take the message out of the queue, then the other receiver who won't.
They won't get it, they'll get the next message in the queue, if there is.
Oh, okay, yeah.
It's more like the service bus if you have multiple instances of one particular worker. So they'll divide it up, but you know,
Okay.
that's it.
Right, mostly for performance, right?
Yeah.
And then you gotta worry about things like if one pulls a message off the queue and then crashes, what happens?
Okay, yes.
So you guys haven't seen, Tom did a presentation for us a few years ago, I think now, or was it last year? This was last year? Okay, so there's probably a video out on the site, he did a great talk on AngularJS, so if this lasts a little bit here on AngularJS, interested, you did a great talk on that last year, so definitely check it out. And thanks Tom for coming back.